So, how are you today? So, hopefully everybody enjoyed this subject. So, I like to start. Thank you for your participation of this consultation. We like to review briefly what happened for this subject for last couple of months, and we want to go for your question and answer. How can I help you to resolve your problem for the assignment 3? Let me share my slide. Can you see the slide?
Yes, we can see, Professor.
That's great. So, congratulations, everybody. It looks like a lot of students have received very positive marks. I look at the assignment 1 and 2. So, it looks like a very good result you have. Now we have last assignment, and then we can discuss today. Before that, just briefly remind you what did you study so far, and then what's our question and answer. So we already learned what's the module 1, 2, 3, socio-technical issues, especially water, potable drinking water from wastewater, and then how this can resolve all the community engagement. And that was the module 1. And module 2 is about how we can design the wastewater reuse plan and comparing with membrane bioreactor system and conventional process. So what's the difference from the conventional technology and advanced membrane technology? We calculate the different membrane bioreactor design, conventional wastewater treatment design. So how much we can save the space, what kind of the energy required, and then overall cost impact. So that's the assignment 2 you have experienced. So module 3, seawater desalination plan. So we already discussed about how we design the seawater desalination plant using membrane barrier, using reverse osmosis processes, and this can be designed by the Wave software. So that's the assignment 3 you have to submit by next week. And this is the detail block 1. We studied about some of the socio-technical system in water management and how we can frame for a socio-technical system to engage our community. And block 2 was about the water quality parameters, guidelines, types, was wastewater and wastewater treatment technology, and then design a water treatment plant. So block 3, the reverse osmosis, already you are now is very familiar with reverse osmosis, how it works, and how we can calculate all the different flux and different membrane selection and design, and how to design for a desalination plant. So that's what we have discussed so far. So now is task 3. We want to see your design skill, and then we want you to focus on how to look at the future seawater desalination, and then background, what's the importance and the related issue for desalination, Also, you need to design for 250 million liter per day and watch the process flow and detailed design of the RO process. Also, provide a comprehensive literature review of impact for brine disposal. This is the current status, but in the future, brine mining would be a good potential to recover some of the resource. So you can also mention about the comprehensive strategy for sustainable brine mining development using seawater desalination plant in Sydney. And you can make a general conclusion and you can have a reference. So that's the all about the assignment 3. I'd like to thank you, everybody, and I'm sure that you have learned a lot from this advanced water and wastewater. You should have a very good confidence of designing water and wastewater, seawater desalination using different technologies, so that this will be very much a project-based assignment. So you can utilize the practical application for your job opportunity in the future career. So that's the all about our mm, brief summary of the subject. So let's start. What kind of question you have, and how can I help you for your subject? So if you have a questions, please you can just turn on your microphone and then ask me question. Also, you can turn on the video so we can have a face-to-face discussion. Anybody questions? Anybody?
Professor?
Yes, what's your name? RR? I can see only RR. Okay, Lutul, yeah?
Yep, we got the data for the current plant, like it's 250 mld per day. So,
Yep.
but it would be too much bigger for a for the software to sustain that big value. So, like we have to divide it into the separate trains. So, in how many trains we could divide this value?
Uh, it's up to you how many train you can divide,
Mm-hmm.
uh,
Mm-hmm.
depending on your design parameters.
Mm-hmm.
What's the capacity you like to design from your Wave software? What's your preference for your
Like
design?
I have tried different trains, but
Uh-huh.
what the problem with my software was, like it couldn't process the summary report. It says that Wave has failed to converge the report.
Because your design may not be suitable. That's the reason why that it's very difficult to calculate your all the flow and the membrane element module. So if you design something is not appropriate, so lies your summary report is not really showing the outcomes. So can you share your mm, screen, and then can you show your Wave software here?
Because the device which I use the software is currently not available, so literally I cannot do that right now.
I see. Okay,
Uh,
so let me show you just the example.
okay.
Okay, so let me share my screen again. Let me share. Can you see the screen?
Yep.
Okay, so you go to your software, and then you can click the open project, right?
Right.
So there are several examples from your project. So you can select one of them,
Mm.
and then you will see your example of seawater desalination, right? So this is the
Yep.
design for 72,000 cubic meter. So which means you can multiply by the 250 megaliter per day, especially product water. So this one has to be careful. It's not about the feed water altogether 250 megaliter per day. The product water should be in total of the 450 megaliter per day. So you can multiply by the 31,000 cubic meter per day. So how many trains you can design based on your product water to make 250 thousand cubic meter per day. So you can divide the 250,000 cubic meter per day by the 31,000 cubic meter per day. So how many train you need to design? So this is the one of the example. So based on
Yes.
this one, yeah, you can have a design of your product water, and then
Uh,
yeah, feed water is already given,
mm,
and reverse osmosis. I think that you may get the error message, or you cannot generate the summary report because your design of this element, pressure vessel, and then feed flow
mm,
rate, permeate flow rate, and recovery would not be correct. So you can just refer to some of the example file from the library, or and you can
library.
try to change. Then you can click this one, and you will have yeah, good
That come.
report from this software. So I think the issue will be your design parameter for this stage one, stage two, and flow rate, and then flux could be wrong design. That's the reason why
Mm.
you have not the correct summary report. So can you please start with the example file, or make just a simple, let's say, one, because during our class, so
Mm.
we had a good example, like very simple 300 cubic meter per day,
Mhm.
and just a small amount of your volume and how much pressure vessel, how many elements, what's the flux of the element required. So you can practice with the small scale, and then you can enlarge the overall your feed water based on your number of trade. Otherwise, you can just refer to the example from the library, and then change the little bit of your feed water capacity, product water, can make your design better. So that's you can have a better approach to complete your summary report.
Professor,
Yeah.
I didn't get got one thing like the one you explained in the feed water and the product water.
Uh-huh.
So if for example my feed water is to 250 cubic per meter cube, so my product water should be like nearly half of the feed water because of the 50% recovery rate.
Right. So when you design for 250 million liter per day,
Mm.
so this is about the product water we have to produce, not the feed water. So which means if you have 50% of recovery rate, so your feed water should be double, right? So it
Yeah.
should be 500 million liter per day of your feed water have to be included. But it's true, it's a very big number you are designing from the beginning because we don't want to use one train. We want to use several
M-
trains.
Multiple.
Yeah, multiple trains. So I don't want to give you the how many train would be the best. I generally say that it's up to your design. So you can make a smaller one, smaller capacity of feed water, and then make a more train. Or you can have a little bit larger capacity and then less train.
Mm.
And definitely your train will impact your pumping cost, the also energy recovery cost, and different elements. You have to incorporate so many trains each, so that I prefer, yeah, around 250 megaliter per day. Personally, you can have maybe 10 to 20 train would be ideal, but as your assignment, you can make your own way of the train design. So I don't really make a specific the train the number, but you can decide by yourself based on this web software. You can connect your final train numbers.
Okay. And sir, can you go to the reverse osmosis, please?
Yes,
So, sir, in that, why couldn't I edit the flux over here?
uh, flux. Yeah.
I couldn't edit the flux.
Okay, this is the given number. So you just you don't some of the system they just
Mm.
fix the flux. So in this case, you don't have to change
Uh,
the your
Manual
flux.
input.
Yeah, yeah.
And sir, like in the stage, in the terms of stage, we have to make a two-pass system, and stage would and what should be the stages in each pass?
I think that I prefer to have a two-stage because you want to have a seawater desalination and the recovery is relatively high, so that you need to increase the stage. So the two stages are ideal for your assignment. So I like to have a two stage here, and then two pass as well to remove the some of the boron concentration. So that's the I prefer you to design for two stages, two passes.
What I did was
Mhm.
I put two stages in one pass and the one stage in another pass. So is it an ideal one?
Uh, I think that I like to have a two stage, two pass, something like
Okay,
two
in the both
stage.
pass.
Yes, this way. So you can have a two stage, and then you have a two pass, one pass and second pass. So you can design two pass and two stage system will be
Oh,
okay. This one is the one pass. Pass one, it should be two stage, but pass two can be a one stage. So you
okay.
can design such a way.
And sir, like in our assignment, we have to also include the process diagram. So, but this software doesn't generate the process diagram. So what should we do about that?
Okay, so you have example. Do you do you have example of the assignment?
Yeah.
for the assignment 3. So if you see the assignment example, so what's the
The
your
good exemplar.
yeah example, good example. So you can see uh, they just mention about screening, prefiltration, and different chemical dose and the pre-treatment and reverse osmosis post-treatment. So when you
Mhm.
have a pre-treatment ultrafiltration, you can mention about ultrafiltration. When you have a dual media filtration as a pre-treatment, so you can utilize your pre-treatment for your dual media filtration. So you can just create the diagram, and that's the you can drawing from the PowerPoint or maybe
Okay.
some of the drawing software, Visio or some other software you can utilize. So you can follow the diagram like how seawater intake and then pH adjustment and chemical dose and chlorination was
Okay.
pre-treatment, de dechlorination, reverse osmosis. So you can draw based on your design. So what kind of design you like to do, whether you want to do ultrafiltration, pre-treatment,
Mhm.
or dual media filtration, you can design for your process diagram, and then you can have a specific design one by one based on your diagram.
Okay. The process in exemplar is different from ours. I think so.
Because this is
Mhm.
example. You cannot be exactly same as your design
Okay.
process, so you can change whatever you like.
Got it, sir. Thank you, sir.
My pleasure. Any other questions?
Professor,
Yeah.
yeah, I have a question regarding the good exemplar. I want to know the good exemplar you provided is the same marking rubric like us.
Same rubric, you can utilize that. That's okay. So what kind of rubric you just see from the example?
Oh, I mean not the rubric, the the report format. I think.
Left format, you mean the background and then
Yes, yes,
design?
yes.
Yes, I think that you can follow the similar example of subsection, subtitle, and then you can design your own way from this subtitle.
Yeah, thank you, Professor. Another question is, in my wave design, I use the product water by scaling down into 250 meter cube per day. But due to the wave arrow design warning, I have to slightly change the element in state or something. And after changing this, there is no arrow design warning, but the product water is change into 240 something, just slightly reduced. Is that okay, Professor?
That's all right. That's okay because no matter what you design, yeah, always there is no such a perfect design conditions, so that whatever you have a little bit of change, yeah, you can little bit adjust based on your design final product. Because even during the summertime, winter time, even aging of your process pump membrane, so you change slightly so that you can have a little bit of change of standard deviation. So that's not a big problem.
So, my last question is, in my RO design, I use both H2SO4 and anti-scalants. Is that make sense, Professor? Two, two chemical dosing.
Chemical dosing, H2S for anti-scalant makes sense because you just report to your summary report. So it shows the RSI for the scaling potential red color, which means you need to add the anti-scalant or pH adjustment to avoid or minimize your potential scaling. So this is the good approach. You can add your H2S of anti-scalant will be a good design approach.
Thank you, Professor. That's all of my question. Thank you.
Thank you, Kin. So we have Yan, Hanadi. Do you have any other question? So we have Mohammed here. Hanadi? Okay.
All good, sir.
All good?
Yes, sir. All good.
So if you don't have a question, so you can continue your design. And then if you have any problem, just send the email or just let me know, and we can have a Zoom online meeting, or we can communicate through email. So you can continue to try to design the seawater desalination plant.
Professor.
Yeah.
There's a section in our assignment rubric that brine mining from the desalination plant. So what we have to actually do in that section, because it says that you have to propose a comprehensive strategy for sustainable brine mining development in Sydney. So like we have to propose strategies, or we have just to give the frameworks regarding that factors.
I think that you can give a little bit of strategy and framework together.
Okay.
So how you can effectively recover your resource from seawater brine, how you can make a strategically sell this kind of application of the resource. So that's you can mention about in your report.
That should be theoretical completely, right, sir?
I think that you can add some diagram if you have any specific process to make your resource brine mining, such as magnesium, calcium, lithium, or some of the compounds you like to recover, and then you can utilize the diagram. Okay, this is the way I like to recover calcium, magnesium. I like to recover lithium and then sodium chloride, some of the useful mineral from brine. So you can draw your diagram as well as the theoretical, your strategic planning to make a good comprehensive approach to brine mining. Is it okay?
And sir, in the reverse osmosis part of the wave software, which membrane model we should select?
I like you to select HR. So there are just let me share the screen. So you have a element here. You can select the SW30HLE. So SW30HL means the high rejection. So you can select some of them, 440 or 440I. So you can select the SW30HLE module type will be the best to produce your overall rejection of the boron and then your salt. So this is the recommended your membrane element selection, HR.
I think my problem of not getting the report file, because that lies in this one. I think I made a mistake in selecting the module. element type?
First, you download some of example file of designing this web software. Then
Okay.
just open for your summary report, and then based on that, also you can utilize the library. So some of the library you just open, and then you can select one of example, and then
Examples.
how this can make good summary report. So just first double check, and
Okay.
then you can decide what could be the your design, and then how you can create your summary report.
And the recovery in this part, it should be between like 40 to 50%, or exactly the 50%.
I prefer 42 to 50. I think the 45 is okay, 50 is okay, because every the seawater, it's depending on your design parameter. But if you have a high recovery rate, you will have a more fouling potential. So 43, 45, even 48 would be all right. So it's not really very important. So you can
Okay.
just put based on your design parameters, which you can handle better. So between 40 to 50, so you can select this one of the recovery rate. But in this condition, real application, normally 43 to 45 would be the ideal. I recommend. But this is
Okay.
the minor. You can select your recovery rate. So 40 to 50, I'm fine with that.
Okay. Okay, sir. Thank you so much, sir.
Any other questions?
No, sir.
Otherwise, you continue your good work, and this is your last assignment list, so that you try to play different your design parameter, and then main objective is how you can familiarize your design of your process, and then outcome would be not really successful. Maybe your software is not really working well based on your design. But while you are doing this kind of experience, then you will understand how the people to make this kind of design very much time, and very much changing, very much effort they have to put the reverse osmosis membrane process. So that's what I want you to experience from the assignment 3. Okay, thank you everybody, and then hopefully you can enjoy for your assignment 3 and submit by the due, and we will get the good marks for your subject. Anytime, you are very welcome. Also, still the student survey is open, so please finalize your student survey, and then we can also improve based on your good comment for the next year, and then how we can make a better design of this advanced water and wastewater treatment subject. Thank you.
Thank you, Professor.
Thank you, Professor.
Thank you.
Thanks. And Professor, can I just show you, as I said in the email, just
Right.
the reason why I can't maybe share my screen, and because I couldn't download the wave file.
Yes, can you show your, yeah.
Yeah.
I stopped the recording, so it should be all right.
Yeah, so I created an account.
Yep.
And when I signed in to download the wave,
yeah,
it's always displaying that we couldn't request.
Page no longer exist. Yeah, something we can process a lot of water right now. Up to 25 million gallons processed every month. But can you put the Google and then just to put the wave software, wave software, yeah. Yeah. Okay, so you can go, yeah, this one, yeah, design software. Let's start this one. And
so I'm signed in.
Same, okay, let me go down. A second, yeah, download software. Can you put here download software? We're gonna process that, the request.
But yeah, if it doesn't work, maybe I can go just to the UTS classroom.
Can
because
you?
I tried many things. So.
Can you, this is very interesting. Can you open for another web browser? Just, yeah, can you open another browser?
Maybe this.
Yes, can you? Yeah, can you put wave here? Yeah, there are always some problem which very difficult to find out. You can go.
Oh, my computer has an issue.
Your computer has an issue?
Yeah, I don't see anything. You still see my screen?
Yes, I can see. I can see.
Sorry, I can't anymore. I don't know why it's doing that.
I can see that. It's interesting. This
yeah,
is
so sorry. Maybe I'll have to turn it. I'm sorry.
Okay, I don't know why you cannot see. I can see your screen. It's big.
I think I can still control it, but I don't see it anymore. So I'm
yeah.
gonna turn off. I'm gonna try to on this new search, but if it doesn't work, maybe I'll just go to the UTS because it's in the room we did the tutorial. There's the wave installed.
Yes, you can access anytime.
Okay.
Just you can open from your ID, and then you can, because there are like a lot of computer available, so that you can utilize that. Otherwise, it's very interesting because other students no problem, but only your computer website, even website, I don't know why it doesn't really show such a way to create this kind of problem.
Yeah,
maybe you may have a strong firewall, or you may have virus or some of the issue for your computer.
Yeah, I don't know, but yeah, I think I'll do that. And
you have another computer or only this?
No, only this one. Coming from France,
so
I only took.
maybe during the weekend, maybe you can go to our computer room, so you can access and then try. I'm sure that you will experience no issue for the access to the web software.
Okay, thanks.
Yeah.
And just a question about the wave, about wave. So this is only for the part of to model it, like the part about brine, it's completely different from this wave model, of this wave. I don't know how to say. Like it's only for one part. The last part about brine desalination is completely different. We don't have to put any diagram in it.
I think the brine mining, you're talking about brine
Yeah.
mining?
Yeah.
Brine mining, yeah, you can draw some of the diagram for the brine mining process if you like. That's more straightforward and clear.
Okay.
Otherwise, yeah, if you feel, not really necessary, you don't have to put, but I prefer to put the brine mining process diagram as well.
Okay. Yeah.
Okay.
Thank you. So I'll do that, and I email you if I have any more problem.
Absolutely. You're always welcome. And
Thank you.
we will keep in touch, Ian.
Yeah. Thanks a lot.
Okay. Take care.
See you.
Bye.
Bye.
Bye.